I'm William McDonough, and I'm an architect and designer and the co-author of Cradle to Cradle. Cradle to Cradle is something that I conceived with Dr. Michael Braungart, a German chemist. And essentially it's different than cradle to grave. The current linear economy is take, make, waste. And what we're looking at is eliminating the concept of waste. So it's take, make, retake, remake, restore. So essentially the idea is that in the world today, there are two kinds of nutrients. Biological nutrients, which is nature, us, and then technical nutrients, which are the materials we form and reform, and that we can keep them separate. So things that go back to soil are meant to be safe and healthy. Things that go back to industry are meant to be recycled in ways that are propitious for many generations. And we try not to let the technical world contaminate the biological world and vice versa. So cradle to cradle in biological and technical nutrition. And then in circular economies with renewable energy, clean water, and social fairness. Well, I see design as a signal of human intention. So what are our intentions? If we look at what's happening to the planet, and then we ask ourselves, is this our design? Is it our intention to put millions and billions of pounds of highly hazardous material in the water and in the air and so on? Is that our intention? And if it's not our intention, what is our intention? So design is the first signal of human intention. So if you intend for things to go back to cycles and not contaminate the world, that changes your design. So we stop designing things for end of life because we might succeed, whatever that means. So we say design for next use. And that's just a different way of thinking. So your intention is to design something that has a next use. And that changes the way you design things. Well, I think designing for the world that we want to live in means we ask ourselves, what is the right? What is the wrong? What is the good? What is the bad? What is the beautiful? What is the ugly? So if you start with your human values, then you can go to principled behavior. You can move to visions of the future. You can set your goals, strategies, tactics, metrics, and produce value. The problem if you just start with value is you're starting with number. And then you can get to tactics, strategies, and goals, but you never get to your actual values of what is the right and the wrong. So what we find is so many people in business especially, and even regulators, they end up looking at the numbers. And they start there. And so they start talking about being less bad, as if that's a good. But being less bad is less a number, and bad a human value. So you're confusing things. So being less bad is actually being bad by definition, just less so. So the idea that you could be more good is much more interesting to me. And so then the question is, what is good? And that's a human question, because that's a human value. The construction industry, I think, is one of the exciting places for this, because it's clearly a world of the making of things. And if we look at the history of manufacturing, it starts with hand and execution. That's what it means. That's where it comes from in terms of even its etymology, hand, execution. And the first manufacturing was really bricks and weaving, knotting. It's hand work. And then as we get into industrial production, we called it manufacturing, when actually we probably should have called it machine factory, because all of a sudden the machines come in. And then we move to the robots, and then we move on. And as you look at that, the fundamental making of things does go back to the buildings that we surround ourselves with, because they provide immense utility, and they allow us to do things we might not in the wandering around hunter-gathering. So for the building industries, it's one of the fundamental places for where we take up these issues. And it's surprising that the construction trades and professions were actually the first green industry, because you don't see green industrial design councils, but you do see green building councils. So I think there's something inherent in the nature of the making of buildings that people want to make the world better while they do that. And they last, and they're around, so they become a significant contribution to society. So wouldn't it be great if they were good instead of bad? I think cradle to cradle is hard for some people, if they've been inured to the cradle-to-grave methodologies, it's hard for them to think it through because they're not used to thinking about what's next. They're trying to get through the day. So it's the difference between a kind of timeful mindlessness, where you're in a hurry and you don't want to think about it, and a kind of timeless mindfulness, where you really are thinking in the long term and the short term simultaneously. So most people, I think, though, inherently understand it, that it's hard not to want to leave the world a better place for the children. So anybody who gets open to the opportunity and starts to see that it actually exists, then it's possible. I think Leibniz said, when something is possible, therefore it exists. But for most people, it has to exist before it's possible. So our job is to make it exist. Then other people can say, oh, this is possible. And once they see it, it's obvious. Cradle to Cradle applies so broadly to the human experience that everyone in the process of a building can get engaged with it, and they do at various levels. So for the people selecting a site, you start to think about the air quality, you think about the transportation, you think about all the issues of what does it mean to be in a place. And so those issues about could I have access to air, light, energy, and so on become fundamental to site selection. Then if you look at the designing of a building, for an architect, we famously say God is in the details. So we look at that. Engineers say the devil's in the details, but so details matter. So for both, the details really matter. And then in engineering especially, we say, in God we trust, all others bring data. So we end up with this idea of beauty and what is the right thing to do, and that really does get designers engaged. And then we look at what is the technical performance and how do we do that with exquisite grace and so on. So the idea of asking what is the right thing to do, I think, is an important one. And then we can show our skills and our ability to function there. So I think the design community, the engineers, the architects, they love this kind of thing. And they're trained for it. When it comes to builders, they end up loving Cradle to Cradle for reasons that may not be obvious. One is that it brings thoughtfulness to what they do in ways that they didn't know they had. So when we look at materials and say, is it healthy? When you think about it being healthy for the occupants of the building, that means it's also healthy for the people building the building. So the actual workers love it because they're not being poisoned all day or having to wear masks or being afraid of the building itself because they get to do that. And so they get excited. They go home and tell their kids they're doing something different. So builders love it because the materials are nice. So that's fun too. As far as the people who occupy the building, the issues of indoor air quality have become very serious a lot of places. And as far as the businesses are concerned, why would you put people in a building that could give you endocrine disruption or make you sick? And so people more and more are finding that not only are the buildings designed with these materials and these ways much more productive. One of them has just been declared one of the most productive buildings in the world, right over here. And the people love it. And so the performance of people goes up. That's worth a lot in the business, but it's also worth endless health and goodwill for the people who work there. So they know that they're being cared for and taken care of, and they shouldn't have to worry about these things. So they just know that people care, and so things are better. They have daylight, they have fresh air, they go home and have a life. Well, if we bring Cradle to Cradle to, say, technical materials in our language, then you end up with a building like this. It's designed for disassembly, so if some point in history this building is no longer needed in this context, all these materials are designed to go back to industry. That means they're actually still perpetual commodities, which means the building has residual value. So instead of having to tear down a building and pay for it to be removed, you actually sell the parts. So as far as the long-term economics go, it's an asset instead of a liability. That's interesting. The other thing that's strange and wonderful is, for example, on the carpets, when we design these carpets, they're not made of PVC, which can give us dioxins and other concerning materials. They're actually thermoplastic polyolefin with a nylon that can be chemically recycled. But they're also free of carcinogens, mutagens, teratogens, so on. So these are healthy materials. Now, when you look at that, we call them products of service. What you want is the service of the carpet, not the ownership of the molecules. You never put in the order for thermoplastic, polyolefin, and nylon, and safe dyes. You want carpet. And why? It's for acoustics, it's for appearance, comfort underfoot, cleanliness, and so on. It's really those services you're wanting from the carpet. So in Cradle to Cradle, the company is delighted to get it back because it is the technical nutrient of their material. In other words, they're storing their raw materials on your floors. That's amazing. So the warehouse is the marketplace. And so it's really not a resource per se, although of course it is. It's a resource because you resource it when you pick it up and provide new ones. But the key thing is you've got a relationship. You're in relationship with the customer because you're storing your raw materials on their floor. So when you come to pick it up, when they want a different color, instead of destroying the world, you're picking up your raw materials, delivering a new one. It's renewably powered. Let's have fun. So it saves the industry. It allows the carpet industry to be perpetuated. We don't have to mine new materials to do it. And so it's cradle to cradle. And in the process, you just provided clean air and comfort and appearance. Buildings, once we get to a certain point, are highly regulated. In ancient Rome, the architects were responsible for the safety of the people who inhabited the building. If people died in the building, the architect was killed. So that was giving the master builders immense responsibility for what they were doing, but it also gave them permission to hold forth on quality because they're taking responsibility. Now, when you look at how you take responsibility, you can either take it because you take it by your nature, or you can take it because it's an engineering issue, or you can take it because you're required to do it. So all those things come into play. But the regulators, I think, are moving in on the issues of health and safety for people in buildings, always have. But it's often been structural issues, things like that. Now it's air quality, it's resourcing, it's carbon footprint, it's all kinds of other issues. So those things will come to play. We like to design regulations out of our buildings, which is not to say we don't like regulation. Regulations are necessary by the guardian and society if they're worried about public health or benefit. But we design things that don't require regulation. So, for example, because these materials in these products are so safe, they're not regulated. So we design out regulation by design because there's nothing to fear. And it requires humility because this is not that easy to do. But there's another reason that it gets us into another aspect of human behavior, which is the issue of negligence. Negligence is proven by showing that you knew you were doing something wrong and you did it anyway, right? So for a lot of people that means I don't want to know because that's their excuse. Oh, I didn't know, so don't tell me, right? So that's one way you deal with negligence. But the other part of it is you're measured against your peers. What should you have known? So we're at the point in history where we know a lot now because we have deep science. And so what should you have known? By putting all this information, making it available and saying, here's beautiful things, here are things that are ugly, here are things that are toxic, and here are things that are safe. You're putting it out in the marketplace, and then the regulators can have something to benchmark. The issue then becomes reducing risk. So another reason that these things become exciting to the commercial actors is you're reducing risk. You're making sure people are healthy and safe so they don't come back and say, how did I get sick? Or what do I do about this building? It's hazardous material. I can't sell it when I'm done. I mean, imagine if we had looked at asbestos when we started putting it all through buildings and said, what if this was a carcinogen? And because otherwise you have these buildings now today that we spend incredible amounts of money just trying to bring it back to something we can inhabit. I think of Cradle to Cradle as a 20-year overnight sensation because I think that for me it's hardly penetrated because this kind of thing takes time. One of the aspects of Cradle to Cradle, the first is material health and safety, and safe for biological and technical systems. And the second is circular economy, which is the reuse, the regeneration, the compostability of various things, that kind of thing. That's second. And we have circular economy second because we like to talk about goods and services. What if you made bads? What if things were actually toxic? Well, if you had a circular economy of bad things, it's worse. So circular doesn't make it a good. So you start with the good, and then you do it again, right? And that's what's happened now, is that the circular economy has now become something with quite a bit of excitement around it. When we published Cradle to Cradle in China, we called it the design of the circular economy. The 12th and 13th 5-year plans of China are called the circular economy. I was the chair of the Meta Council for the Circular Economy at the World Economic Forum. So that's taken a lot of hold in the marketplace, in the minds, which is wonderful. So I think that idea of circular has taken hold. And the part I like is that also people are realizing then Cradle to Cradle, which is circular and healthy and renewable energy and clean water for all children and social fairness, is a bigger multi-attribute approach. And so once you get your head wrapped around any piece of it, you realize it's a whole. And so that's why I think it's exciting to watch people just rise to the occasion. The commercial case is often a surprise. And you open yourself to innovation, and you discover, for example, in the carpet here, when you move away from what you were doing and start to rethink it, it turns out, in this case, it was 10% lighter, which dropped the price, because even the shipping becomes less because the weight's down, and so on. So you start to do things that are fundamentally part of prosperity because you're rethinking it. Just the innovation is itself incredibly valuable as you get into it. The other thing would be the idea of products as services can actually be incredibly cost effective because, as I pointed out, if you have it as a resource and you're storing it with your customers, the marketing cost of your business has just changed dynamically because you're in a relationship with your customer. Whenever they want a new one, you're the lowest cost provider because you're picking up your raw materials. Well, so you can afford to deliver it a better economic relationship. So that's immensely valuable, actually. And then the other thing on the scale of the whole planet that's really important is that if I take resources, say steel or copper or whatever, and we put them in places where they're not working, for example, in vaults, where we have a we say, here's the value of a commodity of the future, I'm going to put it in a vault so I have it as a reference point. Then we realize it's a product of service. If it's not working, it's not an asset. It's not generating capital, right? It's not capital that's working. It's not working capital. So when you think of these as products of service, you're taking the steel or the copper and you're using it, and then you're banking it. So you still get all that value of banking materials for the future because they have value. Now, steel, for example, will have more value in the future if it comes out of a building in a form that can be reused, because it's an engineered thing with performance. If it's just going to be melted, it's not as valuable because it doesn't have the performance. So once you start to think of these things as performing in the economy of the future, all of a sudden you realize I don't need to mine more copper if I use the copper and I store it in a wind turbine or I store it in an electric motor and I know where it is, then we can use the blockchain for this kind of thing. And then you have these perpetual assets. That's how you grow an economy. Because right now we have a spiral economy where we're running out of stuff. What we're talking about with Cradle to Cradle is an economy that grows because we're reusing everything. Well, I think we have to start with the idea of sustainability as a word that is implying something that we need to really think hard about, which is when I won the Presidential Award for Sustainable Development at the White House in 1996, the press came up and said, "Mr. Sustainable, what does it all mean?" And I said, "I'm not interested in sustainability, actually." Because I said, "What's your relationship to your husband or wife?" And you said, "Sustainable." I'd say, "I'm sorry, that doesn't sound too exciting." So if sustainability is just maintenance, it doesn't get us really going. What we really want to have living systems is growth. To have growth, you need income, and then you need an open metabolism of chemicals operating for the benefit of the organisms and their reproduction, right? So sustainability is actually about growth. That's why I like the term sustainable development, because it's really about development. It's really about offering a future that can engage with the past in ways that allow fecundity and joy and expansion. So it's a celebration of abundance, not a bemoaning of limits. So when businesses get into this, what they realize is this is a way of having growth that we want instead of growing the things we don't want. It's hard to know how humans will behave because there are surprising things, you know. This requires immense humility. It took us 5,000 years to put wheels on our luggage. We went to the moon before we put wheels on our luggage. It took us another 20 years to put 4 wheels on the luggage. We had ball bearings for a long time. So I don't know how smart we are, how fast this will all happen, but I think once you get it, it becomes obvious. And I think as we produce buildings that have these benefits or materials and show the finances, more and more people will engage in it. The difference between cradle to cradle, the circular economy, and just recycling, really it needs to be seen as the circular economy for us is not the linear economy moved into a circle. Because if you're just making the same things and they weren't the right things in the first place, and you just keep doing it again, that's not going to help us. It's actually 2 metabolisms, biological metabolism and technical metabolism. And we're taking back things, we're reusing things, and we're having growth. So that's really where cradle to cradle is. And so the circular economy is part of cradle to cradle. And recycling today is often, if it's put in a circle, we might recycle something that was untoward. Most of the time today we see downcycling. We see things losing value, not recycling. So you'll see a plastic bottle that you could drink out of, food grade polyester, terephthalate, and then you'll see that, and then it'll become, a park bench on its way to an incinerator or a landfill. Downcycling, losing quality. What we're excited about is upcycling, where things increase quality. So recycling is just doing it again. Upcycling is purifying it and making the world better. Downcycling is the waste of time, money, and materials. And so the issue of recycling is important, and we believe in that. But the idea that we would actually restore the planet while we reuse materials, and that we keep them at their highest level of value, or in fact even improve them, instead of just let them go down, is really important. If we think about the idea of perpetual assets for generations, then you can look at, for example, metals, say steel. Over the centuries, these are the things that we hammer into other things. Right? We don't throw it away because it's inherently valuable. And you make one thing out of it, and you make another thing out of it. So this is famously what we do with things like metals. It would be wonderful if we start to apply that same mental model to, say, plastics, for example, where they become a durable good, and we can use them across generations. So that would mean they need to be recycled, not allowed to go fugitive into the oceans, or burn it and go to the atmosphere. So things like steel, once we've embedded this effort into it, it becomes a perpetual asset. So if we actually design it to be used over and over again, then it is a perpetual asset. If we design things so that they don't have a residual value, they're torn up, melted, trashed, we're not taking advantage of the moment. So something like steel has immense embodied energy in it that has already created the valuable material that we can use over and over again. So the idea of the material recyclable is actually quite important, because if you compare that to concrete, for example, when you tear down a concrete building, you might be able to use it for aggregate for a parking lot, right? But when you take apart a steel building, it has things that either perform like a beam that still has structural property, or a material that can be reformed into another material. So it has a unique character of being a recyclable, inherently recyclable material. I think what we're about to see more and more, I'm looking at it very carefully right now in the world of affordable housing, that you'll see steel will start to come into its own because it inherently can work in a manufacturing context where you can actually make things and then distribute them efficiently, for example. So I think we're going to see that it rises to its occasion in the industries where it's a replicable thing. We saw it certainly in industrial production buildings and so on. We also saw it in cars. And the cars were made with these metals. And then we see the metal's getting lighter and lighter, and they sometimes will move, say, in transportation towards aluminum because of the weight. And then now we're starting to see that steel's coming back because we can actually engineer steel because of its strength into form factors that are surprisingly strong and light. So all of a sudden you watch these technologies rising to occasion across lots of agendas. So the responsibility, I think, for me, of the people who are working with us are actually the designers. Because if they design it so we can get at it, they've done everybody a great service. And the surprising thing that we've discovered, and seems obvious, and probably it is, that if it is designed to come apart easily, it actually goes together more easily because you've really thought about it. It's quite surprising. We looked at various objects, and when you put them together this way, they go together faster and take less parts. So designing for disassembly is really interesting. And then the idea of developing stock sizes that you can use over and over again, especially, say, in housing, then you could end up with a standard steel beam or column that has a certain length, a certain quality, and then they become fungible. They're currency all of a sudden because you can use them over and over again for the same kinds of things. With the steel in construction, it goes everywhere from the reinforcing iron rebar to high-tech steel constructs of various kinds. So I think it is getting into a library of structural potential. And so we'll see more and more of that, I think. But at a certain point, we see that there are basic materials that we need for basic behaviors. And then there's the specialized. And so the question becomes, how do we keep them from cross-contaminating? That would be one issue, if they could. So just like we see in plastics, if you get a biodegradable plastic and you mix it with technical plastic, you contaminate the technical, you can't reuse it. And then the technical contaminates the biological, so you end up with a product that should not be made. What an interesting idea. So there are going to be steels that have certain properties. We want to really know the properties because they're very valuable. And why would we lose that value by mixing it up with everything into the lowest common denominator? So as we get to specialties, we're going to want to separate them and know how to manage them. If you think of a building as a material bank, you imagine a building like this. Let's say that this has a 15-year investment cycle, mortgage or financing or lease or whatever it is. And let's say you sell or rent that into the market. And 15 years from now, like we saw in Amsterdam in 2008, all of a sudden, the market disappears. So we could look at our buildings, you'll see here. These are designed to be housing in the future. So you can first release a building as a next use, or you could repurpose it. So we design office buildings to become housing, because then you instantly have apartment building, just like that. That's amazing. So that's giving a value going forward. Then if you get to the point where you're going to tear it down for a park or a skyscraper, whatever you're going to do, and this is where steel becomes especially valuable, is that if you demolish a building here, it's about 80 euros a square meter to have it removed. And the concrete becomes aggregate and everything else is a big tangled mess. If the building is steel and designed for disassembly, then it's a material bank, because now we can sell the commodities into that market, and steel will always be valuable. So copper, glass, right? So they get articulated that way. And that building might be worth 100 euros as commodities. So your difference is 80 euros of cost or 100 euros of benefit. It's starting to happen now that we've put the concept into play. It's just beginning. To us, it's obvious, but it hasn't become obvious to everyone. It's a little bit of a long-term play, because when you start talking about 15 years, a lot of people go, I'm out of here by then. I'm not worried about it. So what we'll do is identify the value, and we can put the value into the commodities market and price it. That's when things start to get people paying attention. Cradle to cradle is endless. That's the point. There is no beginning. There is no end. So you could study it mathematically, and it's a science. You could think about it and explain it to your children, and it becomes a belief. We're in a period of high flux and innovation, and we have plenty of work to do without arguing about things that when you think about climate change, for example, I mean, all these years of arguing about the skeptics, it is what it is. Well, I think the key to this is that we don't get stuck on one thing or another. There's a place for everything. So in some places in building, we would use wood. And there are places where we would use concrete, like floor, so on, certain kinds of structures. But steel has this incredible flexibility, so there's a place for it. And it reminds me of a strange source of business advice was Jerry Garcia of the Grateful Dead. They asked him, what was it like to be the best rock guitarist in the world? And his answer was, you don't want to be the best of the best. You want to do what only you can do. Is steel the best material for structure? It sure is when it's the only way to do what you want to do. So, sure.